So basically, we are working on exercise 12C. Two sessions are already done on this particular topic, and both the recordings I have just shared with you. Okay, so exercise 12C, question number 8. Question number 8. Three persons have four coats, five waistcoats, and six hats. Find in how many ways they can put on the clothes. Okay, now we'll first discuss about person number 1. Okay, exercise 12C, question number 8. Yeah, it's on chapter 12, page number 20. Now, person one, number 1, he can wear coats in four ways because there are four options. Four coats are there, so he can utilize any one option over there. And he can wear waistcoats in five ways because there are five options. Okay, and he can wear hats in six ways. So for person number 1, the number of ways are 4 into 5 into 6. So person number 1 can, wear these things in total of 4 into 5 into 6 ways. Okay. Person 2, he can wear he can wear coats in, see, person 1 can wear in four ways, but then he will select any one coat. So now if person 1 is selecting one coat, okay, the number of coats left will be, you can put it on the chat box. For person 2, the number of coats left will be, waiting for your answer. Correct, 3. Some students are replying, so that's correct. There will be 3 coats left because one is utilized by person number 1, and he can wear waist coats in four ways. And he can wear hats in five ways. So one ways I have reduced from person 1 to person 2. Okay. So person 2 can, that's any person out of the 3, can wear in 3 into 4 into 5 ways. Now for person number 3, for person number 3, third person, I'll just write it in blue over here only. Number of coats will be, anyone? Person number 3 can wear coats in how many ways? I am not getting replies from most of you. So can you just tell me? Person number 3 can wear coats in how many ways? Hello.
2.
Person number 3 can wear coats in two ways. Okay. Person number 3 can wear waistcoats in three ways and hats in four ways. So you have to write that information for person number 3 as well. So for person number 3, you just make this particular chart for the better understanding of the paper character. Okay. Now total number of ways. They are asking the different ways in which they can put the clothes. So grand total, the final total for person one, it was 456. For person two, it was 345, and for person three, it was 234. Okay, that's it. So you can just calculate this methodology I've given you.
So why aren't we like adding?
Okay, so that's a good question that you have asked. See, because person number one will put on the clothes, right? Then we'll say and. As per English usage, we'll say and. Na? And further, person number two will use his options, and person number three will use his options, his or his options. Okay.
Okay, sir.
So whenever it is and, we use multiplication. Fine. So that was all about
Yes.
question number 8. That was all about question number 8. I hope everybody has understood this. Yeah. Let us go to question number 9, which is also pending in this particular exercise. If out of 6 flags, any number of flags can be shown at a time, how many different signals can be generated or made out of them? Okay, so there are 6 flags. Any number of flags can be shown. Okay, now case 1, only one flag shown. Only one flag shown. So this can be done in how many ways? 6 ways, because there are 6 different colors. So for example, there is red, green, blue, yellow, orange, black. Okay, or rather I should say white. Okay, 6 colors are there. So at a single point of time, when only one flag is shown, we can show only one color. No? One color out of how many? Out of 6. So there are 6 options in front of us. Or now this time we cannot say and, we have to say or, because any number of flags can be shown. No? So it can be one flag be shown or 2 flags be shown. That way it has to be. Fine. So case 2, 2 flags shown. So total will be, for example, there is flag 1, there is flag 1 and flag 2. Flag 1 can be shown in how many ways? Can someone tell me? Hello. Flag 1 can be shown in 6 ways, because there are 6 flags. And and we are supposed to show 2 flags at a time. Okay. Flag 2 can be shown in 5 ways, because one flag is already utilized. So flag 2 can be shown in 5 ways. The utilized flag cannot be used once again. So it will be 5 times. Okay. Case 3. Okay. So if you have got this concept, what is case 3? Can you tell me? Hello. What is case 3? Now this time in third case, how many flags can be shown? 3 flags can be shown. Okay. So or case 3, 3 flags. So flag number 1, flag number 2, flag number 3. Flag number 1, how many options are there for flag number 1? 6 options are there. So if we have to raise the first flag to make a signal, okay, there are 6 options in front of me. Then second flag, 5 options, and third flag, 4 options. One option will reduce, because the used flag cannot be utilized once again. Cannot be utilized once again. Okay. Or case 4. 4 flags can be shown. Okay. So total over here will be 6 into 5 into 4 into 3. The first flag can be shown in 6 ways. The second flag can be shown in 5 ways. The third flag can be shown in 4 ways. And the fourth flag can be shown in 3 ways. Okay. Now while generating the signal, I can show 5 flags at a time. 5 flags this time. So next case will be case 5. 5 flags shown. So 1, 2, 3, 4, 5. So the first flag can be shown in 6 ways, second in 5 ways, third in 4 ways, fourth in 3 ways, fifth in 2 ways. Or the last case, out of 6, all 6 flags are shown at a time. All 6 flags are shown at a time. So total will be, the number of flags are 6. So it will be 6 into 5 into 4 into 3 into 2 into 1. First flag can be shown in 6 ways, and I have to show the second flag as well. Hence I'm using and, hence multiplication. Second flag can be shown in 5 ways, so on and so forth. Now we have to find out the grand total. Grand total is equal to case 1 or case 2 or case 3 or case 4 or case 5. So you can add all these cases. Individual cases you can solve and add. The answer for case 1 is 6 flags. The answer for case 2 is 30 flags. 30 signals, sorry, not flags. The answer for case 3 is you can multiply this. Case 4 you can multiply this. Case 5 you can multiply this. Case 6 you can multiply this. And finally you can add all the cases. Okay. Yeah, so I think question number 8 and 9 are covered up. Let us go to the next page. Okay, so in next page there is question number 17. So that we need to address right now. Question number 17. Okay. How many 7-digit numbers can be formed using 1, 2, 0, 2, 4, 2, 4? Okay. Now see, remember there is 0 present over here. So whenever 0 is present, don't use that NPR method. You might get confused. Okay. If 0 is not present, then you can very well use NPR method, because first digit cannot be 0. So we have to make a 7-digit number. So case 1, let the 7-digit number start with 1. Okay, this is first case. Last digit is the units place. Okay. Now 1 is already utilized. 1 is utilized and the place is fixed and the object is also fixed. Object at place number 1 is fixed and that object is 1. Number starting with 1. Now here the remaining places, the total places are is equal to 6. Total objects, which objects can be used? We can use 2, 0, 2, 4, 2, 4. So the total objects are 6. So for the case 1, the answer for case 1, the answer will be NPR. Okay. So what I'm doing is NPR I am not using right at the beginning because 0 is present. So I'm breaking down it into cases and then I'm using NPR. Arrangements using NPR. So 6p6 upon 4 is getting repeated twice. So 2 factorial for 4 and 2 is also getting repeated thrice. So 3 factorial for 2. Okay. So the answer for the first part is 6 factorial upon 2 factorial into 3 factorial. This is the answer for the first part. You can solve this, you can simplify this, and you can get the answer. Okay.
So how are the total objects 6?
See, because one object is already utilized at the first place. That is 1. So if the number is starting with 1, it's a 7-digit number. The arrangements are supposed to made from year to year. So this
But how do
object
we
and
know
this,
that we have to start with 1?
see, there are 4 objects, I should say. One of the objects is 1, second object is 2, and the third object is 4, right? And the fourth object is 0. A 7-digit number cannot start with 0. So I'm taking cases. Case 1, let the first object start with 1. Are you convinced?
Yeah, okay.
Okay. And the arrangements are supposed to made in the next 6 boxes. Okay. So 6 places are there and 6 objects are there. So don't consider one once again. Okay. And the answer of this part is over here. I hope everybody has understood and copied this. Yeah. Case 2. Again a 7-digit number. Let the number start with 2. Let the number start with 2. So these are the remaining places. These are the remaining places where we have to make the arrangements. So the objects for these places. I'll just write down the object list for these places. So the places are is equal to 6 because there are 6 boxes which are remaining. So the places are only 6 because we are supposed to arrange numbers only in these places. Because the number is starting with 2. 7-digit number is starting with 2. So we don't have to consider this and this. Don't consider this object and this place. Okay. So the objects which are remaining n, I'll just write down the object list for you. It will be 102 424. Okay. So we have to utilize all these objects in these 6 places, right? So the total number of objects are 6. NPR 6p6 upon 4 is getting repeated twice. 4 is getting repeated twice and 2 is getting repeated twice. 2 is getting repeated twice. Okay. These are the remaining objects. So don't consider this 2 once again because that 2 is fixed at place number 1 and the that 2 is not supposed to get arranged anywhere else. So arrangements are happening only for these 6 objects. These 6 objects at the 6 places. Which 6 places? This 6 places. Fine. Okay. So this will give you 6 factorial upon 2 factorial 2 factorial. 6 factorial 2 factorial 2 factorial. Okay. Case 3. See, the 7-digit number can start with 1, that case is already over. It can start with 2, that case is also already over. Now the third case, the 7-digit number can start with 4. So case 3, the 7-digit number can start with 4. Obviously, the 7-digit number cannot start with 0. Any 7-digit number cannot start with 0. So this is 4. So the arrangements are supposed to be made over here at this 6 places. At this 6 places. Okay. So for here, the places, total places R is equal to 6. Objects R is equal to 6. But in which 6 objects? We need to write that down. 1, 0, 2, 4, 2, 2. See, we have the object list. We have the object list over here. See. So उसमें से 1, 4 I am eliminating. So these are the 6 objects which are remaining. 1, 2, 0, 2, 2, 4. 1, 2, 0, 2, 2, 4. 1, 2, 0, 2, 2, 4. Yeah, fine. So these are the 6 objects. Arrangements are NPR 6P6 upon 3 factorial. Why 3 factorial? Because this 2 is getting repeated thrice. So this is 6 factorial upon 3 factorial. And finally, you can write the grand total. Case 1 or case 2 or case 3. And the meaning of or is addition. Meaning of or is addition. I hope everybody has understood this. Okay. Remember, this 2 is getting repeated thrice. It's an identical object, same object getting repeated thrice. Hence, I have written upon 3 factorial. Okay. Next, we also have not done question number 23. So let's start with question number 23. Find the number of ways in which 5 identical balls, that means the balls are same. Okay, exactly similar. Like the previous problem, some objects were repeated. Okay, can be distributed in 10 identical boxes. See, there are 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 5 balls which are identical, same balls. Okay. So first ball, ball number 1, can be distributed in anyone? How many ways?
10.
10 ways. Correct. Good. Because there are 10 options. So ball 1 can be put in 10 ways. So this ball, for suppose I'm putting it over here at position number 4, at box number 4, sorry. Okay. Ball number 2, I'll say and. As per English usage, I will say and because the second ball is also remaining. This can be distributed in 9 ways. Why 9 ways? Because see, there are 9 boxes which are still empty. Okay. For example, the second box, okay, second ball can be placed over here. It can be placed anywhere, but then I'm taking an example. And ball 3 can be placed in 8 ways. And ball 4, 7 ways. And ball 5, 6 ways. Understood? Are you able to understand this? Okay. As one ball will reduce, the number of options will also reduce. Fine. Ball 1 can be distributed in 10 ways, ball 2 9 ways, ball 3 8 ways, ball 4 7 ways, ball 5 6 ways. Okay. So total number of ways is equal to 10 into 9 into 8 into 7 into 6 upon 5 factorial. Can you tell me why am I putting this 5 factorial? Anyone?
Because all the balls are identical.
Yeah, because all those 5 balls are identical. So, there shouldn't be any double counting. Fine. I hope you understood this. Okay. First, the arrangements. Okay. I'll tell you why we do that 5 factorial. See, if suppose I'm placing the balls like this is one way of arranging. This is one way of arranging. If I replace this ball with this ball and this ball with this ball, will we count this twice or only once? We cannot count this twice now. It will appear to be the same. The balls will be arranged at 2, 4, 5, 6, 7 box number only. Even if we, shuffle it. Okay. So to avoid double counting, we are doing that 5 factorial. And this we do generally when the objects are identical. Yeah. Next problem. Question number question number 26, I think I have done. 24 I have done. Let's go to question number 25. Okay. In how many ways 5 prizes can be distributed among 4 students when each student may receive any number of prizes? So prize number 1 can be distributed in 4 ways. It can be given off in 4 ways. There are 4 students. Any student will get any prize. So likewise, prize number 1 can be given to any one of the 4 students. And prize 2, again it can be given in 4 ways. And prize 3, again in 4 ways. It can be distributed in 4 ways. Prize 4, 4 ways. And prize 5, 4 ways. And these are different prizes. Okay. Prize number 1 is, let's say it's a drawing competition. Prize number 2, let's say it's a debate competition. Prize number 3, it may be some other competition. Okay. These are not similar prizes. So identical objects are not there into picture. These are different competitions and different prizes. So a person can get all the 4 prizes. Okay. Or he might get one and the rest of the 3 prizes can be given to someone else. Okay. So any number of student can get any particular student can get any number of prizes. So prize number 1 can be given to student number 1 2 3 4 as per whoever wins the competition. Prize number 2 also can be given in 4 ways. Prize 3 also 4 ways. 4 and 5 also 4 ways each. So the total number of ways is equal to 4 into 4 into 4 into 4 into 4. 1024 ways. 1024 ways. 1024 ways. Okay. Yeah. Let us go to question number 26. Question number 26. In how many ways can 3 letters be posted in 4 letter boxes? Okay. First part of the problem. There are 3 letters and there are four post boxes. Okay. Letter number one can be posted in 4 ways. See, on day one, if suppose there is one person by the name Arjun, he is going to post a letter. So there are 4 letter boxes in front of him. So he can put that letter in any one of those 4 boxes. And second day, some other person, let's say Arkin, is coming to post a letter. Okay, he can post it in 4 ways because there are 4 letter boxes. So he can put in any one letter box. And letter 3 can be posted in 4 ways. Third day, third person. Okay, for example, Akshay sir, he comes and post in, he comes with a letter and he can post in like 4 ways. There are 4 letter boxes in front of him. Fine. So the total will be 4 into 4 into 4, whatever it is, 64 ways. There are 64 ways in which the letter can be posted. Okay. Next part of the problem. If all the 3 letters are not posted in the same letter box, find the uh, find the corresponding number of ways of posting. See, one cannot post all the 3 letters in. In the second part of the problem, the nature of the question changes. Okay. Post box number one cannot have all the 3 letters. Okay. Post
So
box.
one second, you go back.
Sure. You can take your time to grasp this.
Yes, sir.
Okay. So the condition put in the second subpart is, in post box number one, all 3 letters cannot go. What are the number of ways in which all 3 letters can go in post box one? Anyone? Post box one, two, three. All 3 letters over here. What are the number of ways in which we can put all the 3 letters in first post box? In which all 3 letters be posted in first box. Equal to one way. There is only a single way in which all the 3 letters can be posted in one first post box. And there are 4 post boxes. Okay, I've drawn only 3. Sorry. What are the number of ways in which all 3 letters can be posted in the second post box? That's also one way. Number of ways all 3 letters can be kept in second box is equal to one way. There is only one way of putting all 3 letters in one box. And in third box, initial statement will be the same. That is also one way. And all 3 letters in the fourth box. This is also one way. Now tell me guys, are these 4 ways allowed or not allowed? This is a total of 4 ways. Are these four ways allowed or not allowed? Just read the problem. You need to read the problem clearly. Yes, yes, guys, please tell me. Are these four ways allowed or not allowed? Guys, these four ways are not allowed because we cannot post all three in one box. So the total number of ways in which all three can be posted in one box are four. Individually, one plus one plus one plus one, that is four ways. Okay. So I'll just write it down. Number of ways in which all three letters can be posted in any one letter box. I should write any one, okay? Any one letter box is equal to 4. How 4? I've already explained. This is first way, then this is the second way, third way, and fourth way. So these four ways are not allowed. Okay. So what we can write over here is the three letters. Okay. If all the three letters are not posted in the same box, find the corresponding number of ways. So for the second part, the total number of ways will be 64 minus 4. Why 64 minus 4? Because 64 are the number of ways in which there is no restriction. We can put any number of letter in any number of letter boxes. So this does not have any condition. Okay. अभी इसमें से four ways are such that all three letters will be in one letter box, any one letter box. So that we need to subtract. So 60 are the total number of ways such that any number of letters can go in any number of letter boxes, any letter boxes, provided all three cannot go in one letter box. Okay. All three cannot go in one letter box. So that was question number 26. After 26, there is circular permutation, which is obviously not there for your syllabus as per your uh, school, as your school decided. Okay. One last problem I will take, and that will be the end of it. This will complete permutation once and for all. Okay. So let us go to question number 15, 1 5. Okay. This is just a recap of the previous class. There are five boys and three girls. Five boys, B1, B2, B3, B4, B5. And there are three girls, G1, G2, G3. There are three girls. Okay. In how many ways they can stand in a row so that no two girls are together? Okay. Now first we'll arrange the boys. Boys can be arranged in this manner: B1, B2, B3, B4, B5. Okay. Now star be the place where you know girls can stand. No two girls are supposed to be together, meaning is they will be separated with a boy, or they can also be at the end point, at the extremes. Okay. So girl 1 can be arranged in one, two, three, four, five, six ways. And girl 2. Now, one of the ways occupied over here, for example, the first place is occupied with the girl number 1. There are five more places for the remaining two girls. So the second girl can be arranged in five ways. And for example, girl 2 is arranged over here. Girl 3 can have four places. It can go and sit in any one of the four places, the four options which I've shown. Okay. So the star indicates the place for girls. Okay. And boys, total, there are five boys. Number of objects are five. B1, B2, B3, B4, B5. There is no condition on boys. Places, For 5 objects, there will be 5 places. So this will be 5p5, which is equal to 5 factorial ways. For boys, the arrangement will be 5 factorial ways. So finally, the total number of arrangements will be 6 into 5 into 4 into 5 factorial. 6 into 5 into 4 into 5 factorial. Okay. So this problem also is done. Now in exercise 12C, except circular permutation, we have completed everything. Okay. That's it.